Hey guys, so this video is to go over the stuff for Unit 3 that will be on your final. I won't say that this is everything, but this is the majority of the stuff that you'll need to know in order to be successful on your final. Remember, there's a review guide in the back of your workbook, pages 247 to 259, I believe. That is another review guide that you can use to study. But I'm going to go over this Unit 3 stuff so that you can kind of review with me. At any time, feel free to stop the video, try things on your own, and then check back to see if you've got them right. So Unit 3 was all about distribution, and we had three types of distribution that we were looking at: probability distribution, binomial distribution, and normal distribution. So I'm going to go over all three of those here. So probability distribution, remember, you had some sort of outcome and then the probability of that outcome. So there were two requirements for a probability distribution, and it was that the sum of all probabilities equals 1. So if I add all of these up, it should equal 1 at the end. And then that all the probabilities are between 0 and 1. So you have no negative probabilities and no probabilities greater than 1. So to find your mean and your standard deviation of these, to find the mean, we did x times p of x. So we would multiply our x value times our p of x value. So 0 times 0.5 is just 0. 1 times 0.26 is 0.26. 2 times 0.19 gives me 0.38. And 3 times 0.1 would give me 0.3. So then if I add up these values, that will give me my mean. So if I add up 0.26 plus 0.38 plus 0.3, that tells me that my mean is 0.94. So then to find our standard deviation, we used x squared times p of x. That was part of the process. So you'll square this value and then multiply. So 0 squared is 0 times that would give me 0. 1 squared is 1, so that's not going to change this value. 2 squared is 4, so 4 times 0.19 would give me 0.76. 3 squared is 9. 9 times 0.1 would give me 0.9. So I'm going to add up these values now. That doesn't give me the standard deviation, but it is a value that we need. So here we get 1.92. So then to find the standard deviation, we're going to take the square root of this value, 1.92, subtracted from our mean squared. Sorry, that should be a 4. It doesn't look very pretty. So I'm going to take the square root of 1.92 minus my mean value squared. And that gives me 1.018 or 1.02 as my standard deviation. So then another part of our probability distribution was those expected values, which is the same thing as finding the mean. It's just in the context of a problem. So for instance, our example here, you participate in a school raffle, you pay $10 for your ticket. If you are picked first, you win $2,000. If you're picked second, you win $1,000, and there are 500 tickets sold. So if you want to pause the video, try this on your own. I think that's a great idea. If not, I'm going to go over it. So the event in words, the possibilities of how this could play out for you. You could get first place, you could get picked first, you could get picked second, or the only other option is that you lose. So then in terms of what do you get when these happen? So if you lose, all that happened is you lost the $10 for your ticket. If you get first place, you win $2,000 minus the $10 that you put into it. So you would end up winning, right? You'd walk away with $191,990. And then the same thing for second place. You would win the $1,000 minus the $10 that you spent on the ticket. So you would end up walking away with $990. So then what's the probability of all of these taking place? Well, if there's 500 tickets told, that's our total. The chances you get first is 1 out of 500, right? They're only going to pick one first place winner, just like they're only going to pick one second place winner. So then that means everybody else out of those 500 tickets lost. So if only 2 of them won, that means 498 of them lost. So then to find the expected value, we multiply these together. right? Because we're finding the mean. So we multiply them together and then add. So I would take 1,990 times 1 divided by 500. I get 3.98. Then I do 990 times 1 divided by 500, and I get 1.98. And then I do negative 10 times 498 divided by 500, and I get negative 9.96. So when I add up all of those values together, I end up with negative 4, which means most people, right, the odds here is you're losing money. You're not winning. All right, so that was kind of the biggest things out of our probability distribution. Another note here is that we always talked about unusual results in probability distributions. An unusual result is if it was lower than 0.05. So this one would have no unusual results. All those are greater than 0.05. All right, so then for our binomial probability is when there's only two outcomes, either success or failure. So you did it or you didn't do it. So this is how we found or calculated our binomial probabilities. And then again, to find our mean and standard deviation looked a little different from this one. We just multiplied n times p together and the square root of n times p times q. So if we look at some examples, on any given street, there's a 63% chance a house has Christmas lights on it. If we went to a neighborhood with 40 houses, what's the probability that exactly 25 have lights? So N, P, and X are what we're looking for. N is your total number of houses, or total number. P is your probability. And then X is what you're looking for, or the outcome that you're hoping for. So in this case, we went to 40 houses, so N is 40. Our probability is 63%, or 0.63. And then we want to know if exactly 25 houses have lights on them. So then X would be 25. So then when we go to calculate that, we hit second vars. We go down to our binom PDF. Our N value, or our trials, is 40. Probability 0.63, and our X value 25. So we get that our probability here is 0.1291. So then our next one asks us the probability of 15 to 18 houses have lights on them. So still our N is 40, P is 0.63, and now X has a couple different values. So it's 15, 16, 17, and 18 that we're going to look for. So remember when we did that, we could even copy this one because our 40 and 0.63 stayed the same. We're just going to change this value to 15 and calculate. We'll change it to 16 and calculate, 17 and 18. So once we calculate for all of those, then we'll add those values together. So we'll take this, then hit plus, go up to here, plus this one, plus this one. So when we add those together, we get 0.0151 as our probability. So this one is just adding up multiple values. A quick reminder, if it's asking like less than 2, remember that 0 is a value. So if I was asking less than 2, you would have to consider X equals 0, 1, and 2. So just don't forget about 0 in those instances when you're solving. All right, so if we turn our paper over, and I might keep this one showing just so we have our mean and standard deviation there. When it comes to going out to eat, a food critique states a restaurant only gets the order correct 70% of the time. We sample 30 random people in order to find who ordered from the restaurant to find out if their order was correct or not. Find the mean and standard deviation of the number of orders we expect to be correct. Then find the interval of ordinary values. Would getting 27 out of the 30 orders correct be unusual for the restaurant? So when we're talking about a binomial distribution, our mean is just multiplying our N value times our P value. So in this case, our P value is 0.7, 70%, and makes our probability 0.7. And then we talk to 30 people. So our N value is 30. So if I multiply 30 times 0.7, I get 21 as my mean. And then to find the standard deviation, we do n times p times q and take the square root of that. So your n and your p value are the same. So my n is 30, my p is 0.7. And then remember, q is just the opposite of p, or the failure of p. So if there's a 70% chance that they get it right, that means there's a 30% chance that they get it wrong. So then if I multiply the square root of 30 times 0.7 times 0.3, I get a standard deviation of 2.51. So then to calculate our interval of ordinary data, right, ordinary data lives within 2 standard deviations of the mean. So to calculate that, you would take your mean and add 2 times your standard deviation, and then you take your mean and subtract 2 times your standard deviation. And that gives you the range of ordinary values. So if I do 21 times, or plus 2 times 2.51, sorry, typo, and then I do 21 minus, I get that 15.98 to 26.02 are ordinary values. This gave me 15.98, 26.02. So my range is 15.98 to 26.02. So is 27 unusual? We would say yes, because that lives outside of this interval that we just created. This is where the ordinary values live. So basically like 16 through 26 is about how many that they're getting right in an ordinary solution. So that wraps up our binomial probability. Yeah, being able to calculate a probability and then being able to find your mean, standard deviation, and interval of ordinary values. So then when we talked about normal distribution, we talked about our empirical rule, where 68% of your data lives within 1 standard deviation, 95 within 2, and then 99.7 is within 3. We turned things into z-scores so that we could compare 2 different distributions by making them the same. So we'll do that as well. And then a z-score between -2 and 2 is usual. Anything outside of that we would consider unusual. So we did this a lot when we were comparing like test scores. We'd make both of them z-scores and then compare who did better. So some things that we did, we would take a bell curve, right? And we want to know what's greater than. In a normal curve, our mean is 0 and our standard deviation is 1. So if I want to know the value is greater than -0.49, that means I'm looking for this shaded area here. So that's when we use our normal CDF with our lower upper bounds, mean and standard deviation. So if I go second vars, normal CDF, my lower bound here, right, is my -0.49, and then I'm going to the rest of this graph, so 1e to the 99. My mean is 0, my standard deviation is 1. So then my probability is 0.6879. And if you're doing less than, then your lower bound would be that -1e to the 99. So we did a lot with when it was in standard normal form with our mean of 0, standard deviation of 1, but we also did ones where it was in a context of a problem. So nearly 85% of college students are employed in a job for at least a portion of the school year if the average monthly income was $1,865, the standard deviation of 120. What is the probability that a student is making at least $2,000 a month? So the average monthly income means that that's our mean, right? Our mean is 1,865 and our standard deviation is 120. And then I want to know students making at least $2,000. So this is my center. And I want to know people making at least $2,000. So 2,000 or more. So we're still going to do our normal CDF. Our lower bound is 2,000. Our upper bound is 1e to the 99 because we're going for the rest of the graph. Our mean is 1,865 and our standard deviation 120. So when I solve that, normal CDF, 2,000, 1e to the 99, my mean, I'll blur it out for you. So my lower bound was 2,000, my upper bound 1e to the 99, mean, standard deviation. So then my probability turns out to be, now, we should see that this is negative and red flag, red flag, red flag. This means that it doesn't like that we typed in 1e to the 99. Sometimes that does that to us. It just is a fluke. But remember, your probability should always be between 0 and 1. So a negative probability is a huge red flag. So what I'm gonna do is, instead of using 1e to the 99, I'm gonna change this to a number that's significantly bigger than 2,000. So let's try like 10,000. And if I run it now, then I have a probability that makes more sense. So sometimes that happens. It's not very often. You shouldn't expect that to come along, but you should know that if you get a negative probability, that something has gone wrong. So make sure you just pay attention to that. So 0.1303. All right, so then another part of this is if we know the probability, but we're trying to figure out what number that represents. So for instance, a particular university will only consider applicants who score in the top 40% on the ACT. If the mean is a 24 and the standard deviation is 3, what is the cutoff score? So I know that on my curve, I want the top 40% of answers. So that means roughly about this, right? If this is my middle, it's a little bit past 50, a little bit more than 50%. So this is when we used our NV norm. Now you have to be careful depending on the calculator that you have. If you have a newer calculator, NV norm, you can pick, right, that we're using the right side of this graph. So we would say we want the top 40% with a mean of 24 and a standard deviation of 3. Oops, I shouldn't have closed that parentheses. And I'm going to use the right side of this graph. So when I do that, my area was 0.4. My mean is 24, and my standard deviation is 3. And then I'm using the right end of this graph. So then that tells me that my cutoff score is 24.76. If my calculator does not let me decipher what side of the graph I'm using, you just have to know, right, if I'm doing 0.4 and over, if I'm doing the top 40%, I messed up this picture, guys. Top 40% would not be that far, right? Top 40% means lower than 50. If you caught that, I apologize. So it should look more like this. Yeah, 40% is less than 50, not more. So this is wrong. My apologies. The top 40% would be over here. Still the same cutoff score, which makes sense. It should be greater than 24. If 24 is in the middle, it should be more than that. But if I'm only doing 40% here on the right, then that means what I'm doing on the left would be the other 60%, right? The cutoff score is giving me this exact location. It's talking about what the value is at that 40% mark. So if we do the 60% mark coming from the left, we get the exact same value. So if your calculator does not let you decipher, your calculator is automatically coming from the left side. So when you do your NV norm, I'm going to use 0.6, 24, and 3, and then I'm going to come from the left because your calculator will automatically assume left, and I get the exact same value. So just depending on what calculator you have, you can use, depends on which one you use. So that is the review on Unit 3. Again, I would go back and look at the video, or look at the pages 247 through 259 in your workbook for extra practice, but hopefully this kind of refreshed you on the main stuff we saw in Unit 3.